Here we go. Activity 1.1, circle parts and bisectors. Just a quick heads up because I was just listening to the first video. My pug obviously can't breathe, so if you're wondering what's that noise in the background that's sounding like something can't breathe, that is my pug. She's beautiful, but show you some pictures later. So starting with activity 1.1. Of course, you all don't have the tools because I'm choosing not to risk anything being stolen or lost or whatever the case may be. Not saying I don't trust you, but just being able to prevent all these unnecessary actions if they do ever happen. Please don't forget you have some key vocabulary words right here. Most definitely, you do know what a radius is. You do know what a diameter is. This is a new vocabulary word right here, central angle. But let's go over the parts. Using a compass to construct a circle in the space provided and label the center point O. So we have a center point O. If you had a compass, just like I don't have on myself, but of course you would put the metal piece in the middle, use your compass to a certain measure, and then go around as you would. Now, it is important to know that the measure of the compass when you have it out, that is your radius. So of course the radius is the same without the whole thing, and I'm just gonna write that little note. Our compass measure is our radius. Number 2, use the definitions to complete the construction and answer each question. Construct the diameter of the circle. Label the endpoints D and M. Point O is the midpoint of the diameter. So we finish out this thing. That's my dog, sorry again. Bringing out a diameter, making some endpoints. They want us to label D and M. Of course, this is a diameter because it completes half the circle. How many central angles and arcs are produced by drawing this diameter? This is where it gets a little bit interesting. There are 2 central angles. We have 1, we have 2. We just discussed right before the test what these angles entail because it is a linear postulate. So, recalling what a linear postulate is, our 2 angles are each 180 degrees. Because obviously if this is 180 and this is 180, then the full circle is 360. Also, there are 2 arcs. We have the first arc, and then we have the second arc. There are 2 arcs as well. Can we give these arcs a name? Of course, nothing too crazy, but because it's half a circle, we will just call this a semicircle. Beautiful. Construct a perpendicular bisector of the circle's diameter. Label those points of intersection P and B. So all it's saying is, can we construct a 90-degree angle through here? You should be able to. I'm gonna give a little example right here, just into relation without our compass. This is D, this is O, this is M. Got it from over here on the top, of course. Remember, when we draw these arcs, you will come to this endpoint, make a mark, come to this endpoint, make a mark with the compass. That intersection will show a perpendicular intersection. And when it hits the end of the circle, they want us to label it P and B down here. We can talk more about this when I come back to campus. Next page. Okay. Use the definitions to identify the circle parts and answer each question. So again, there's some key words right here, of course. Sorry, the table's a little messy. Please make sure that you become more and more aware of these vocabulary words. I'm very happy with the way the book has laid it out. Letter A, identify all the drawn radii of the circle created by the diameter and its perpendicular bisector. Okay, gonna make a small picture of what we created a little bit earlier. It's not gonna be a beautiful picture, but it'll be a picture. DOM, something like this, right? That's a terrible circle. And then when we had our line that came through, that was point P. This was point, I forgot, let me go back, give me 1 second, point B. And this radii would be O to D, O to M, O to P, and O to B. So we're just labeling all our radiuses. Perfect. What central angle and arcs are produced by the diameter and its perpendicular bisector? Of course, we have this arc, this arc, this arc, and this arc. So we produced 4 arcs, and now there are 4 angles. Of course, because we know this is a perpendicular bisector, we know that all those central angles are 90 degrees. So I'll write that real quick. 4 central angles, all 90 degrees. And then we have 4 arcs as well. Draw a line through 2 of your label points on the circle to form a secant and a chord that is not the diameter. Use a protractor to measure the angles of the triangle and a ruler to measure the side lengths. So of course, if I were to replicate this circle real quick, give me 1 second. Sorry, that's my dogs. We have DOM. This was P. This was B. We know these are all 90 degrees. And if we draw a secant and also a chord, we could call this one a secant because it's a line. And we could say this is a chord, segment. It wants us to talk about the 2 triangles that we created. We should know that this triangle in the inside, we created 2 right triangles. If we took it a step further, not only are they 2 right triangles, but they are two isosceles triangles. How do we do this? We should know the measure of D to O and O to B, D to O and B to O are the exact same length because they are the exact same radius. Same thing from P to O, M to O. These are the exact same thing. So we have a side angle side triangle. We want to be extremely specific. We can also say that these angles are the same. We could get more in depth, but of course, we don't want to scare us. But that's the basis of the whole thing. Now, we do need to also mention the degrees. So we know that angle POM is 90 degrees. If we want to talk about these two little angles, we can say OPM. Angle OPM is 45. And OMP is 45 degrees as well. How did I do that? Well, we know that this central angle is 90 degrees, and we know a triangle is 180. So we take this, we divide it by 2 of 90, which gives me 45. Okay? Of course, I'll mention that once I come back. Going to the next page. Compare your circle diagrams with your classmates. Did everyone create the same triangle, the same type? Of course, this is all on your own. Definitely good conversation. Don't get distracted. This stuff can be very difficult if you're not watching very carefully, so I do recommend keeping in mind to try your best. Let's see if there's the next page. Activity number 2, we are almost done. I'll do the next video.